Hello, everybody. Hello,
Hello.
Um,
hello.
Hi everyone.
Welcome, everyone, from wherever you are and whatever time zone you are, to this episode, especially in an special time here today, because of time zone here. So, let introduce everybody here first. First, our host is here. Hey, Chila, how are you?
I'm fine, thank you, Pedro, Eduardo, and Igor, and everyone who is joining us today. So I'm excited and looking forward to this conversation because it's somehow different from the conversations we had before. So I'm interested in any questions and all the answers.
Thank you, Chila. And Igor, how are you?
Hi Pedro, hi Tila, hi Eduardo, and everyone that is watching us. It's a pleasure to be with you guys here. Today we will talk a lot of different stuff, like especially on the career path and how far this can take you in a very interesting field that Eduardo went through, that is software engineering research. And it's just one more option for all of you guys that are watching us, that software engineering is not only coding, is not doing just little things and getting the next one. We will discover much more, and I'm looking forward for that as well here with our special guest.
Yeah, and our special guest today is uh, is a PhD in software engineering. Is a fellow friend from ITA in Brazil, Aeronautics Institute of Technology, and one of my first mentors in my career, Eduardo Guerra. Hey,
Thank
man,
you
how
very
are you?
much. Yeah, fine. It's a big pleasure to be here today, talking about what I do and what I love to do. And yeah, so in the end, maybe you will see that's not so different. Maybe the we talk about the same things, coding and all this stuff. It's also a part of our routine. And I'm really glad to get this invitation. And thank you also for adjusting the time zone so I could participate.
Yeah, about the time zone. Where are you?
I'm in Italy right now. I live in right now. I'm in Bolzano. I live in the city of Trento. It's more in the north of Italy. So this region don't speak only Italian but also German.
Yeah.
So yeah, and I work here in the Free University of Pozzo in Bolzano.
That's
That's
amazing.
awesome.
And then
And
he go on, Pedro, go on.
yeah, please.
Hi, Eduardo. Hi, everyone watching us. And I would like to ask you, Eduardo, have you started your career as a researcher here in Brazil, from what I got from what Pedro mentioned? And did these research um, take you to Italy? How that happened, and how did you enter in the researcher field? Because that's a very unknown career path for most of the engineers in the market.
Okay, so I let's say it was never like a long-term plan to become a researcher. I I graduate, so I start working with Pedro. We were in the Brazilian Air Force. We worked with software development. Um, During this period, we literally worked below the school we studied, so it was kind of close and easy to do the master. By this time, I remember it was like 2002, so like it was like the it was the time that the agile movement was starting. So my master thesis went in the direction of a refactoring of test code. You see that we don't speak so much different languages, so it's kind of something that you do. So I did my initial research on this, but let's say when I finished my master, I didn't immediately think about doing the PhD. But then, okay, also inside the Air Force, I have this opportunity to do full time, this time PhD. And after 6 months doing the PhD, since okay, it was the school that I studied my graduation, my master, I worked below it, so everybody kind of knew me. I get the invitation to become a teacher there. And then that's, I think, when I fall in love with doing research, because in my PhD, I also have the opportunity to work with framework development, more specifically, the frameworks that use metadata, the frameworks with that use the annotation, which was like 2007 when I started. So it was like when this kind of framework was appearing. So I think also the topic kind of threw me also in the PhD. And then this experience of doing research, supervising students, teaching, I thought, okay, this is what I want to do. Then I a bit after, so I keep in the same place after I finish my PhD, also as a teacher for 2 more years. Then I enter in a public organization in Brazil in a researcher position. It was the institute that do like space research in Brazil, but I worked with software engineering because you can imagine that there are many software projects in places like this. I stayed there for 7 years, also working a master on a PhD there, and then there was this opportunity to come to Italy. Initially, I wanted the idea was to come for 3 years as a temporary, let's say, experience out of Brazil, but also then I adapted here, also my family, and then we decided to stay.
Absolutely. There are different words, and for someone that took so long in this career, because to become a PhD and a researcher and a teacher, it takes time. It's a deep learning and teaching from what I could see if you explained in your career.
We never
And
stop learning, right? So
yeah,
we always need to. It's
I
a career
believe,
that we need always to follow what is happening. And
yeah,
Exactly.
I would say that in software engineering in general, who stops stays behind, because everything is changing
yeah,
every day, especially these days with the AI boom. It's a changing paradigm. And I believe that in research is the same. And congratulations.
let me know that in this matter we can kind of have some advantage, which
Mhm.
is the fact that you're saying, okay, you cannot stop, otherwise you stay behind. But sometimes depend on the company, also the project you are working, and in many cases you need to work with some outdated technologies and
Yes.
maybe not exactly with what you wanted to work. And in research, of course, I was fortunate that my supervisor kind of trust me to choose my own topic, but it's not always
Mhm.
like this. But I have the fortune, and when we get at some point in our research career, we do have some freedom to choose the research topic. So we are always on what is the most recent stuff, which I know that for some professionals, it's not always the case, because sometimes you get stuck in some project that deal with some or let's say, or maybe it's not because it's old technology, but maybe because something that you find interesting and want to work don't fit in that project or in that part that you are working with. So here we do have a bit more freedom to explore the new stuff, even the stuff that is not even ready to be used, and etc.
Mhm.
In
Yeah.
production, you say, right?
Yeah.
And what is the topic? So, what's your specialization area like? And is the same that you're researching now?
Yeah. So software engineering is a very, very large field, right? I used to say that is the most human part of of the computer science because, okay, if you are talking about large software, it's not going to be just one person developing it. So you do have teams, and you have the team dynamics. And my PhD and my master, they were really, let's say, more, maybe I can say, low level in terms that it was closer to the more technical part, closer to the code. But after a while, I find out that sometimes some things don't work, not for technical reasons, but because of, okay, there is people on the other side. So if it's something is really good, but it's not easy to be used, or maybe can be used by a team, maybe that will not work well. And then today I would say that I work a bit with agile software development. In general, I focus more on software design and software architecture. I work a lot with the patterns community, for example, but I try to explore these things from, let's say, from the code to the people. So then also involving the processes, how people will use it, and also from the technical perspective, then the code quality and the metrics and performance and other stuff. So, but let's say if I have to say one, the core usually is the software architecture that is in the center of this thing. Like if you pick up, it looks like many different things, but in my head is one thing that is connected to the others.
That's great. So, Eduardo, do you guys work on the research and the release of new frameworks that are used worldwide, or specific research that you work on?
Yeah, so in this part of frameworks, as I said, I work with more specifically with these frameworks that use with metadata. So in our case, like it's hard to have a development that gets to production, even because of funding, to have a fixed team. So in many cases, what we do is that we kind of prove concepts, right? So then, okay, we develop a framework that kind of illustrate a concept, an idea, and then we use this to prove this idea. But in the end, okay, usually it's open source, so if someone wants can pick up there. But the idea is not to make it ready for production. So yeah, so then I don't have like a famous framework or something, but it's more like, okay, works that explored these. Just as an example, so we did like a work regarding the how the code annotations from the frameworks affect the code readability, for example, or what is the effect on using one framework approach compared to others. So this kind of thing.
It's kind of more, it's a research on articles that comes with a conclusion about these comparisons, or in the case of the framework comparison, or in the case of the code readability. It's kind of these type of conclusions, these research, right there.
Yeah, so to understand a bit what are the consequences of using things, maybe some things that are new ideas, some things that are the industry is already using, but is not completely aware of the consequences of using that. So just
like AI.
Let me pick up an example that is a bit older, because now we can give a distance to analyze. So when the microservices became a hype, right? So many people sell this idea as the solution to our problems. This is the architecture everyone needs to be using. And then, okay, then people start doing research on that, and maybe some of the initial promises, it was shown that was not like that, or some costs that nobody talked about start to appearing on this kind of research. So then it's like many companies, and we see, I think like microservices is a good example, because we see many companies that step back, right, and move to the monolith or a different solution, and because they adopted a solution that they didn't know all the consequences of making that decision, right? So and this one we can step back, and when we think about the hype that it was and what we know right now, right? We saw that, okay, maybe we didn't have a lot of maturity regarding these things when all these movements started. And about AI, I think yes. For now, AI is obviously is everywhere, even in the research world. I was looking, for example, to a workshop about green software, and there are many papers related to LLMs and AI. So it's everywhere, both for applying AI in software engineering, and developing systems with AI agents. So then both things are a bit separate, because one focus more on the application, the other on the software, the creation of the software itself. But yeah, both are being studied, and for example, what are the consequences of this uh, um, of using AI? So then, as researchers, we try to understand, even propose new ideas that to see if they work, to see what are the consequences, and do that in a more systematic and structured way.
Yeah, I
Yeah.
think this is an important thing that I want to ask is about how this research are executed, because uh, we are not like used to think about research in the scientific structured way. So how do we do this kind of research that you're saying in this structured and scientific way? It's something that we can say, oh no, it's scientific proved that something, because people like to use this word, but we don't know exactly how it works. Can you explain a little bit for us?
Yeah, in the end, let's say software engineer is kind of hard. I remember there was once a discussion. So I hear someone say, "Oh, there was this huge discussion that it's really hard to validate and do prove things in software engineering." And the conclusion was that yeah, it is hard. So it's not much we can do. But in the end, what we try to do is to get evidence. So it's hard to say that, oh, this maybe in some very specific case, yes, but in some cases, like, okay, using this kind of stuff improve developer productivity. So um, yeah, so what we can do is to get evidence that regarding this, and maybe when we're trying to get this evidence, we can find out some interesting things. But proof is really hard, because okay, maybe I did this. I can do an experiment where I compare people using with people not using, but okay, maybe different people would be different. Maybe I can experiment this in a large project, but usually when I do in a large project, I cannot have a control group like doing the same project without it. So then we always have some kind of trade-off, right? So
Mhm.
For example, when we increase the complexity and the size of the case study, usually we can do just a few. When we have more large-scale experiments and research, we can have, let's say, more, but then it's usually something more simple to be able to scale. And then it's interesting to see that sometimes it's hard to know, but then we get some evidence here, some evidence there. One of the sources of evidence we usually get is, for example, evaluate with professionals or ask professionals to give their opinion. But in the end, okay, if I ask 20 experienced professionals about something and they say, oh, this is great, but it's still their opinion. So it is evidence, it is valid, but proof, it's really hard. So what I try to do in my research is to try to get evidence from different perspectives, different angles, to try to enrich the vision we can think or study about some kind of technique or practice and whatever.
So the idea, like getting like surveys with a huge number of people, so we can get some more statistically.
Yeah. So then this will be a more, let's say, quantitative study, but we can also interview and be more deep with a lower number of professionals. So this one will be more qualitative, and then we will try to get some insights about that. So then usually we try to mix stuff and to get these evidence from different perspectives. So maybe we can get more simple information from a lot of people and more in-deep information, but a small number of people. And then, okay, try to triangulate the findings.
Yeah.
And
interesting.
One thing from our audience here. Unfortunately, I think it's Andres.
It's Andres, right?
Yeah.
Hi, Andres.
Hey guys, even in physics, we need evidence to prove that the universe behaves as the math say. Yeah.
Yeah.
For sure.
Exactly.
And then he
the problem is that in physics you can be more precise, right? It's
you
easier
can
to
see
measure.
it. You can see
Yeah,
it. You
and
just
you can
see it
calculate,
happening, right?
Yeah.
As
you
I
can
said, for
calculate the
example,
math.
when you are, I don't know, for example, if you are doing a study of different AI models that you're running simulations, etc., then it's something more, let's say, exact, so that you can actually reach. But when you have people in the middle, and as I said, in software engineering, people is it's an important factor, right? You can have the greatest framework in the world if the people that are trying to use don't know how to use them. It will not work. So then, since we have people in the middle, it's hard to say that like, oh, this team improved the productivity doing this. You cannot say that in another one or in another type of project for another type of software. In another team, it will behave the same. So it's an evidence.
Andrews added something interesting here. It would more like psychology study or medical study.
Yeah, let's say that's a lot of psychology in the middle. That and even many of some of the, not all of them, but some of the research methods we use also come from these ones about the interviews and surveys, come a bit from the human sciences to understand the people perception. Like, as I said, for example, code readability. It's a very subjective thing.
It's very personal to each one, right? How readable is something. And I even think that culturally it changes from someone in Western compared to someone in other parts of the world.
Exactly. So that's why we did a study and we can see who participated, and then in the end, you have to say, okay, but these results are for this type of population, right? To
Yeah.
be able to
Mhm.
generalize, we need people from other places. So that's
And
always
and,
these
and
factors.
about that,
Yeah,
Eduardo, how do you do these research? You do them locally, you do them online. How are these data collected when you need to grab information from people like the code readability?
It's a bit like for each research, we see what are the resources we have, the opportunities we manage. For in this case of the code readability, we did an online survey. In some cases, we do case studies that are sometimes in presence. In other cases, we do like interviews, which can be also online or in presence. So then we try to, as I said, we search for all the opportunities we can to
Everywhere.
gather evidence that can help us to know more about something or some technique.
and you delegate that to your students, right?
Yeah. In most cases, yes. But of course, I already did myself many times. In some cases, also help and yeah. But the when we come past this side, we it's I said it's the dark side of the force, right?
Amazing, guys. I will need to drop right now, but I will be back, I hope, before the ending. So, guys that are watching us, please keep sending your questions here, like Andres just did, and keep enjoying. Hopefully, I'm back with you guys here and with you, Eduardo, before the end. So, see you later then.
See you later.
Yeah, thank you, Igor. Yeah, and it is interesting, say, because we see this kind of studies in universities, but I know that we have some studies being done in companies as well. Like they need to know some to analyze stuff. They are like hiring researchers today for AI or something like that. How do you see this merging between the academy and the companies on this research topic,
I
especially in software engineer?
yeah. I think like for it's also I think it's a bit also cultural. I see, for example, someone with a PhD in Brazil can be seen as overqualified. I already see some videos saying that people should hide their PhDs or something like that.
Mhm.
But for example, I see that here in Europe is not that. Um, let's say it's mandatory, but I think it's something that can help you to uh, uh, um, to get a better job or to get to some more specific tasks, right? I think like one of the things that we learn as researchers is to analyze things in a more systematic way. So I have an experience with some students from a professional master in Brazil that are usually some professionals that have kind of 10 years of experience at least in the market and they come to do a master, so they experience like doing the thesis, so some kind of research work. And the feedback I have from them is that the systematic thinking that they have on thinking how they can evaluate things and in a more systematic way, to don't go for what I think is right, but if we are going to make a big decision, to think about ways to actually evaluate that. So they said like this change on the way they think, on the mindset, it's very important. So this more analytic things, even if you're not going to work with research, I think this way of thinking can help you a lot, even if you are going to the market.
Interesting. Anders is still sending some other questions here. Like also the students that use it to first to fill the surveys, right? So how do you deal with the bias? So, or you ask them not to feel it?
Yeah, so it's as I said, we use the resources that we have access on, and that makes sense. So in some cases, do make sense, right? To for the students to participate. In other cases, don't. So then we spread for in the cases that don't. But in any case, usually we protect also the privacy of who is, not usually, always we protect the privacy of who is asking, but we ask some information, especially about the let's say the experience you have and the background you have. So, for example, in a more quantitative study, we can, for example, to do some statistical tests to see how much that experience influenced that on some answer. So then we can see, okay, this is there a difference between the who is experienced or who is not experienced. In the cases, for
You mean
example,
you
that
mean you mean about like sending the choosing just seniors to do the survey and choosing just juniors to do the survey or something like that?
no, it's, imagine that we have a lot of people that did the survey, both students and more senior. So in this case, we can see, for example, imagine that we have a result, ask if someone finds something difficult to do. So then we can see if this is a difficulty that if the fact that the experience influenced on this answer, right? So we can do a
Okay.
statistical test to say, okay, this is stronger for the student, stronger from the other side. And in the case that we all, let's say, in some cases, make sense to use maybe or just students or mostly students. And in this case, when we analyze the data and do our conclusions, then we consider that that was the population that participated. For example, maybe we want to see how hard was to understand some new API or something like that. And then, for example, if we do with the students, we consider that people with this level of instruction have this difficulty, right? So then we also consider that in the conclusions.
Interesting.
What are you doing with all those research results? I imagine that you are creating research papers and you are publishing at some sites. But how those results flow into, for example, normal software development? So those results, are they coming somehow back to normal software everyday development so that people can benefit for it, or how is this process?
Yeah, this is hard because we need to do our research, we need to publish our results, and even if they are let's say publicly available, some in a scientific journal or something like this, they are not let's say sometimes reachable, or is not something that someone from the industry will go after and find. So then we also need to do a parallel work on spreading our results. So and this is hard. It's not everyone that does that. And for example, I for example always submit also this Friday. For example, we have a conference here called SFSCon that is focused on open source, and I submitted a talk there. I'm going to talk about some project related to green software. Does have some scientific results, but I'm presenting them in a way that for to pass the message for the industry, right?
Mm-hmm.
I
What is
have
the green software?
Yes. So can I just finish? Then I come back to that. Then I have the privilege of participating on two communities that have a lot of people from industry as well. So the Agile community, for example, the XP conference, which is the one, and even next year is in Brazil. That, for example, in the field of agile development, there are a lot of people from industry that also participates. There are like a research paper track, there's industry tracks. So and it's not like there is like one session that only have research papers. It's by topic. So you go to place for a session about hybrid work, you can have presentations from industry and presentation of scientific papers. So it's a place that you already have this mix, and also the patterns community. It's also kind of half industry and academics. So we also exchange a lot of information, see what happened in industry. They see what we are looking for. So I also have this privilege. But yeah, it's not, let's say, it's not an easy question to answer, and it's a lot of work to disseminate your results also among the practitioners. So it's a very interesting question. Now I can go back. Did I answer? So then I can go back to the green software.
Okay, yes.
Okay, so then let me go back to green. So that's what we call green in software and green by software, right? So the green by software is when you try to let's say improve the sustainability by softwares that can help on this, right? The green in software is to try to make your software, independent of what it is, more green, in a sense, like to or consume less energy or consume more clean energy, which can be, for example, to reduce waste. But also you can work with, for example, a load balance that use servers where you have more availability of clean energy, for example. So then, even for example, when we talk about IoT and cloud computing, like the cloud continuum, for example, maybe you have a device that has it's powered by solar energy, and then have some spare processing power that is not being used. So can you use that instead of throwing all the processing to the server where you have a data center already consuming a lot? So all of this is not only, for example, working with the performance, but let's say trying to use better our energy. Nowadays, like with the AI, we have a huge increase, right, in the energy consumption. Today, like the IT sector, it's already, I think, consumes much more than the airspace sector, if I'm not wrong. But the problem is, let's say, think about how many data centers are being built and how many new flights are being created. So we are growing and growing really fast. So if we don't think about this kind of thing, it will be a problem, a huge problem. It's already a problem, but the problem will just grow.
But it's a problem that there are only the academy that is thinking, or there are companies that are thinking as well.
No, I think there are many companies that are already thinking about that in more green solutions, in saving energy. Because okay, if you save energy, you also save money, right? So but in the end, okay, now we need so much energy with the AI and stuff that okay, we need to start thinking about this.
Interesting.
It's a
Yeah.
for architects, it's a new non-functional requirement. It's new quality attribute that we also need to consider and balance with all other stuff.
Interesting. And this is your last talk about some of your results. And do you have other examples that something, for example, some results that you have that could be more broadly discussed, that could help more people if it was more known?
Yes, one topic I'm being explored that is related to software architecture and agile software development. It's about software architecture uncertainties, which what is the idea? Because evolving a software architecture is hard, right? But today we do have, I don't know, systems with more than 20 years old and much more. And if you think about, okay, it's no way they think about the current architecture 20 years ago. So the architecture evolved and evolved a lot. But if we think about the agile philosophy of embracing change, architectural changes might not be so friendly to embrace. They can affect the whole system, can be very expensive. So we can't just, okay, let's say to prepare for an architectural change is not as easy as a change in a given feature, right? So it can have a huge dimension and can be really something expensive and even sometimes not even viable to be done, right? So then, what is the idea? So how we prepare ourselves for these changes? So is to think about the uncertainties in our software architecture. Today, we talk about requirements, right? But when we write the requirements, many of them we are not 100% sure, right? So you are thinking about, oh, this system will need this amount of simultaneous requests, right? But we don't know because how many simultaneous requests even depend on the size of the request. So if it takes longer, probably we'll have more in parallel, right? So then, and many things we cannot predict, and they are very, very important for the architectural decisions. And so what is the idea? Is to manage these uncertainties. So I would say like it's more important what you don't know than what you know. So if you think about that your requirements are important, the ones that you know, the more important ones is the ones that you don't know. And
Okay.
and this is the basis of that. So what I see happening is that when someone writes a requirement, it automatically became, I don't know, something like sacred, or that oh, this is this. Like we sometimes, oh, we need to put something, put a number, but then okay, after a while nobody knows who wrote that, and then we just try to accomplish, right? So then the idea is to, when we have things that we don't know, and these things could be related to the requirements, because sometimes we don't know how the software will grow or what we will need. Even like, for example, with the AI, if we are working with AI agents, we have a lot of uncertainty in terms of reliability and even the resource consumption that they can have, right? Even if can we reduce the consumption by using a simpler model, or okay, so then that's a lot of uncertainty associated. It can be related to the requirements. It can be related also to the technology. Maybe we don't understand this technology yet, so we need to know, for example, does this database will be enough for the data we have, right? So does this persistence will hold our capacity, our scalability requirements? And then what is the idea? To instead of calling these requirements, we can call these things hypotheses. So we call that hypothesis engineering. So the idea is to manage these uncertainties, because sometimes it's okay if we live with them, right? So we don't need to solve all of them, but it's important to be aware of them, because sometimes, even if it's something, I don't know, depends on the business, on the behavior of our users. Maybe we are in a startup, we don't know the direction our business will take. And then, okay, if we don't know, we cannot, let's say, solve this uncertainty, but we can work on the impact. So sometimes we can do some architectural techniques that help us to reduce the impact of not knowing this thing. So then, so I think, like, and this is one of my line of research, that this is a way to handle the architectural evolution, is to manage the uncertainties and try to act on them, to find out what is the right way, right moment to make decisions, and to kind of try to do that. We already did some case studies in real projects, so it's not because we are academy that we don't work with real projects, and we have some really encouraging results on the use of this. And this is something that I really think people should know, right? To think more about what they don't know, and sometimes it's hard, because it's hard, for example, in a team, depend on the company, to say to your boss or to your product owner, we don't know this thing. We don't know if this will hold. But if we don't say that loud, sometimes it's, I usually say this is like the secrets that became whispers in the most hidden places in the companies, which is the coffee room, right? So it's just these things that people whisper, but they don't put explicitly, right? So, but when these are, when this is explicit, then okay, we can handle that.
Yeah, I was thinking that there people from companies, they prefer not say I don't know, but they prefer to say we are like 70% sure that I think it's something like that, right? And I was thinking about what you said, like hypothesis. Oh, we have this hypothesis that we are like 60% sure. We have there's other hypothesis that we are like more 80% sure that's gonna happen, and that not gonna change, or but
think about that. It's different from risk, because if you are 80% sure, then the uncertainty is low. If you are, let's say, it's very unlikely that is there a probability, but it's very unlikely that something happen. Then the uncertainty is also low. So if you are almost sure or almost unsure, not almost unsure, but you are almost sure that this is not going to happen, or probability is very low, then your uncertainty it's low. But the cases that you have no idea is the ones that the uncertainty is high, and these are the ones that you need to act. Like, for example, getting some metrics or doing some spikes.
You mean after the fact? So, for example, we have all these requirements, we work on that, and then after the fact, we have like a system production, and then you have to measure again to compare with the things that we thought,
you can,
and to get new things that we didn't know. Something like that.
Both. In some cases, for example, if you are making a decision in the beginning, maybe you did not make the software yet. If the uncertainty is high, maybe, I don't know, by choosing something that will be very important and hard to change later, you can do some experiments, you can do some measurements even before, right? But okay, but then if your uncertain is would this will hold, this solution will be scalable, then okay, then you get the information from the production, and there is for example a pattern that is called the architectural trigger, which is you have an uncertainty if something is going to happen or not. So you define a trigger like, okay, when this metric get at this point, usually not the place where you already have the problem, but it's getting close to be a problem, then it's when you need to act on that. So then you trigger this thing to deal with that.
Mm-hmm.
Interesting. I'm having a problem, for example, about upgrade of. Let's say we choose some stack, and the stack needs to be upgraded, right? We have new versions, we have security flaws, we have something that performance improvement. We have new versions of Java, we have new versions of Python, and whatever, right? And but all these changes are like are hard to organize.
And always bring uncertainty, especially, for example, if you have a critical quality attribute, and then you think that this upgrade can affect this, and this could be an uncertainty that you can evaluate before the decision that to migrate or not, right? For example, maybe if it's a critical security thing, you need to upgrade. And but the point is, and then you can also work on the impact. If it coming back is easy, then, for example, you might migrate part of your infrastructure, do some measurements in production, or okay, maybe it can be really critical, so let's do some tests before actually upgrading. So, and then when you bring this uncertainty, and it's not like I upgrade or not, but usually when you is thinking about the architecture, especially what is going to be hard, what is going to be more critical to make the decisions. Because if we think about our architecture, there are many things that are pretty straightforward, but there are a few things for our software that really matter, that we really need to be careful, and usually the main uncertainties are around this thing. And then the beautiful of this is that this is completely different from one project to the other. What is critical in one, it's not a problem in the other. So then you need to focus your attentions on the decisions that will have a higher impact. So that's why this hypothesis management it's interesting, because because you know that it's hard to direct our efforts for more technical stuff, because sometimes the clients cannot see value on this, right? And then when we bring these uncertainties and the consequences, it's not that I'm refactoring blah, it's like I'm dealing with this uncertainty, that sometimes the client can see value on solving this, because it usually adds value to the business. So then when you connect what you are doing with these uncertainties, it's even easier to argue with your product owner or client why that is important.
Yeah, and we have some place to keep an eye on it, right? As I said, triggers. Because if we don't write down that all these lines, and if we don't have a place where we'll be constantly coming back and relook monitoring this and analyzing
even
what's happening, and we will never remember, right? But I know that I know for a fact that we can think about something and say, oh, okay, it's not gonna happen, or I don't know if it's gonna happen, and then we forget about it. We don't write it down anything, and we keep working on the next project, right? And then when we get at some point, the monitoring, the data dog says, oh, you're having a problem in our system here. What is it? And then we look at it and say, oh my god, that's what I thought, like half a year ago. It's now happening. Oh,
I have some papers and some studies that I like to call them. Let's show how bad things are, and one of them is about the no, quality attribute requirements, and we find out, for example, one based on the research we did, we find that a lot of them are defined when the system is already in production. So it means like only when the problem comes that there is this performance requirement.
yeah,
And yeah,
it
so
happens a lot,
yeah.
unfortunately. Oh, okay, yeah. Can you? I think we're getting the end of our time here, and do can you say to the audience that are thinking about getting to this path of career, like being a researcher, do you have any advice to them to say, oh, how to get there, and oh, what could what could help them to choose this path of career?
Yeah, I think like okay, it's to get here, you need to do a master, you need to be a PhD. So I think like if you or even I think in the bachelor, you most people do kind of a final work. So if you like these kind of things, right, doing a master's attracts you, some of the topics, it's already some clue that you might like it. So I would say, okay, if you like doing some research, maybe as your final bachelor work, maybe try to do a master, and maybe do a little more. Or if you really like it, try doing a PhD. You can still work in the industry after the PhD. So if you like what you experience there, then this life is for you. I think it's pretty cool because we can do the stuff we like, play with new technologies,
Mhm.
and yeah.
Is there a lot of competition in the research field where you are in, or
Yes,
is?
yes, that's always a lot of competition, and it's for positions and stuff. Of course, I think it depends a lot of on the country. There are some that is easier to get
Mhm.
positions. For example, here in Italy specifically, it's not easy to get a permanent position in research. But yeah, if that's always places to start, and you are always learning. So I think it's not. At least I see here, some people do this transition to industry after a while. So if
Uh-huh.
you decide not to stay in the academia, you had this opportunity to learn a lot, and I think you will be very valuable for the industry as
Oh,
well.
okay. Yes.
As I talk here, like I think it's not as far as the things you discuss in your daily development lives, the things we are researching here. So
Hmm.
Mhm.
That's awesome. And how can we find you in your social media? Do you have any links to send to our audience here? Like
I can send,
your
but
books. I know you have like a lot of books.
yes, I do have two books from in Portuguese in Brazil, in Casa do Código. I have an YouTube channel. I have a podcast, the Hillside Pattern Cast about patterns, and Pedro will be in the December episode. And what else? You can find also me in LinkedIn, which is usually where I post all my stuff. So then I think it would be a good hub
Do you have the
for
link so we can send here to in the chat to the audience?
not right now, but I can send you and okay, in the chat. Okay, let
Yeah.
me. Okay. I did not prepare myself for that. I actually close everything to don't get distracted. Okay, let me.
You can send here in the private chat. So
Okay.
we can send the live chat.
I will send my LinkedIn profile. So I think
Perfect.
these one you can find easily my other stuff.
Mhm.
Okay, I don't know where I put this. Maybe this one. Did I send on the right place?
Yes.
Yes.
Nice.
Can you send here, Chila? Because for some reason, I can't send.
I tried. Just a second.
Yeah, please. So everybody can find you.
And maybe, as you can see, like the time passed really fast. Maybe I can come back in a future episode.
Oh yeah, and
Thank
I
you.
think now we have like some more. You can bring like a specific topic, something that you are like
Yeah.
more interested in you, something that you are like preparing for a talk, or even if you are like more publishing in your social media, something more that not exactly about the researching thing, but the results, and something that you are more interested to
Nice.
share with
Yeah, we
us.
can talk about green software, about software architecture in
Yeah,
agile
so,
environments.
so exactly, software architecture is something that we are always talking here. People love software architecture, and if you bring some
And even
other
like AI
bring
agents,
some good
like
stuff.
it's all to do with also software architecture and yeah.
Exactly. I know that you have like a good course on software and AI agents. So it's something that you can bring for us as well. That's awesome.
Thank you
Uh,
very much
do
for
you
the
have any
invitation.
last words?
Last words. I think like it's do what you like, what you love, and I think you will succeed. So I fortunately find like teaching, doing research, that's something I love to do, and yeah, so I have fun.
Also, thank you. Yeah, any last word, Sheila?
Yes, so thank you very much, Eduardo. So it was very interesting conversation. So I got a little bit of insight what you are working on the topics. So I have a much better image in my head right now what you are doing, and I found it very interesting. So thank you very much.
Thank you.
Yeah, and my last word is thank you, Gerhard, to join us, even to get to try to find a book a moment in your calendar. I know that you're very busy, and all the students and all this all these other reviews that you have to do, and any PhDs and masters and etc. So thank you
For
very
you, I
much.
always find time. Uh, only the time
I'm
zone
always
that
your
was
fan.
hard to find the middle term, but we
Mhm.
managed.
That's awesome. Thank you so much. Oh, Igor is here, like in the very end. Let's put Igor here and to say his last words.
Yeah, well, I was kind of trying to follow during my meeting, but I was not able to hear everything. But thanks a lot, Eduardo, for bringing us here this subject. It's a very different and interesting subject for everyone. It is a software engineer and wants to know the paths that exists beyond senior, and this is one of the very interesting ones that you can kind of shape the world, not the software engineering world, but it's very interesting, this kind of research. And thanks a lot for bringing us the word and what you do here. Congratulations on your career, and I hope all the best there in Italy.
Thank you very much.
Yeah, thank you very much. So, and for all the audience, thank you very much for being
Yeah.
here, and hope you'll be here in the next one.
Mhm.
Absolutely.
Okay,
Thank you,
thank
Bye
guys.
you.
bye.
Take
Bye.
Thank
care.
you.
Bye
Bye
bye.
bye.